How was the Vena del Gesso formed? To understand the origin of Romagna's Vena del Gesso, gypsum vein, we must take a step back to about 16 million years ago, when the entire Po Valley, as well as much of Italy, was submerged by the sea. Where today we can admire the mountains of the Tuscan Emilian Apennines, the sea reached a depth of a few hundred meters, and the seabed dropped continuously due to subsidence, a phenomenon that still occurs today in the Po Valley. But what happened in the depths of this ancient sea? The erosion of the alpine chain accumulated large quantities of detrital sediments at its edges. Shaken by violent earthquakes, the sediments generated massive submarine landslides, called turbidites, sliding downslope for kilometers and kilometers along the seabed and depositing enormous volumes of sand and mud. These sediments have been deposited for a few million years in the gradually sinking sea basin, forming a sequence up to 3 kilometers thick. It is the Marnoso-Arenacea formation, composed by the alternation of two rocks, marl, a more or less calcareous clay, and sandstone, a cemented sand. Unlike marls and sandstones, gypsum and rock salt are among the few rocks that dissolve in water. When a sea basin is subject to strong evaporation and reduced water circulation, the minerals forming rocks, called evaporite minerals, precipitate from seawater and settle at the bottom, similar to what happens in commercial salt works. 6 million years ago, in an era that geologists defined as Mycenaean, the entire Mediterranean Sea turned into a gigantic salina, as shown by large and thick salt and gypsum deposits. These deposits, and therefore also our Vena del Gesso, are in fact the testimony of one of the greatest ecological catastrophes in the history of the Mediterranean Sea, the so-called Mycenaean salinity crisis, which caused the disappearance of almost all marine organisms, unable to live in such a salty environment. Only a few species of bacteria have managed to survive. But what caused this catastrophic event? Continents have not always found themselves in their current position, and even today they move slowly as if they were drifting rafts. The collision between the European and African continents led to the formation of the Strait of Gibraltar, the only point in the Mediterranean Sea where there is an exchange of waters in both directions with the Atlantic Ocean. Today, this canal is only 14 kilometers wide and about 300 meters deep. About 6 million years ago, however, it was an even narrower passage that allowed ocean water to enter but prevented the very salty and therefore denser water from leaving the Mediterranean Sea. For 640,000 years, the salt and gypsum have been deposited on the seabed, forming layers of salt up to 2 kilometers thick in the deepest areas, and layers of gypsum of over 200 meters in the marginal areas. This is how our Vena del Gesso came to life. If we observe today the Vena del Gesso along the gypsum slope facing southwest, we notice that the banks are separated by thin clay interlayers. This is due to the variation of climatic phases, each of which has left its mark on the rock sequence. Every 20,000 years, the climate switched between arid moments when the gypsum was deposited and humid moments, during which the sedimentation of the clays took place. In the following 6 million years, until today, the Vena del Gesso has undergone many and substantial changes, such as the uplift of the Apennines, with the disappearance of the sea, very large landslides, and more recently, man's actions. The geological factors over time have deformed the Vena del Gesso gradually, producing the current spectacular morphology.